Hello everyone, this lesson we're going to discuss Lab 7, 3-phase power measurement, use 2 wattmeter and the power factor corrections. So we use a motor as an inductive load. We have 2 wattmeter, each of the wattmeter, the current coil connect on one of the line to measure the current, and the voltage coil gonna connect onto the third line to measure the voltage. And we have a voltmeter to measure the line voltage. We have an ammeter to measure the line current. The motor we're using is 3-phase motor. The rate 230 volts, and the FLA, the full load amp, is 3.4 amps. So for the motor, we first connect motor in the circuit. We don't have any load on there. The motor have a power factor below 50%. When the motor have power factor below 50%, one of the wattmeter gonna raise positive number, and another wattmeter gonna raise negative numbers. You can see when we go to the lab, one of the wattmeter, the needle actually gonna flip down to the negative side. So for that, if we want to get a reading, we have to flip the connection for that wattmeter to let the wattmeter take a positive reading. But when we calculate the total power, we have to use 1 wattmeter reading, subtract another wattmeter's reading. Then when we add a load on there, in this lab, we're going to use an eddy current breaker as the load on the motor shaft. So when we turn on the eddy current breaker, we put in load to load the motor up. The motor's power factor going to become higher than 50%. When the motor's power factor higher than 50%, both wattmeter are going to raise positive number, because before we flip the wattmeter, now when the motor, both wattmeter raise positive number, we have to flip that wattmeter again to get a positive reading. At this time, when we do the calculation for the total watts, we have to add 2 wattmeter reading together now. So here's how we're going to use 3-phase, use 2 wattmeter to measure the 3-phase power. At the same time, we're going to use a capacitor bank to do the power factor corrections. When we load the motor to the full load, the motor is going to draw 3.4 amps. But that's at a lagging power factor. So when we put the power factor correction capacitor in there, when we correct the power factor, the motor line current is going to go lower than the full load amps. So we can see that through the lab. Next one, I'm going to show you through the lab. So, we got a 3-phase power from the top supply to the bottom bus bar. We hook the 2 wattmeter down here. Each wattmeter, the connection is come from one of the supply line. Then the voltage coil, the connection is from one of the supply line. Then they both go to the center line. This wattmeter, the current gonna go through an ammeter and go to the motor. That's our voltmeter. We try to measure the line voltage. So we use this 2 wattmeter. We're going to try to measure the 3-phase power drawn by the motor. So first, I'm going to turn the power on. When I turn the power on, this wattmeter has a positive reading. So the wattmeter goes to positive side. And that wattmeter, you can see the needle go downside. So which means that wattmeter is reading negative number. At this moment, I don't have any load on the motor, so the motor's power factor is below 50%. That's why one wattmeter reads negative. So I'm going to turn off the power. I'm going to flip the lead so I can read the positive number. I switch the leads on this wattmeter. When I turn the power on, Now both the wattmeter will have positive reading. But for these two wattmeters reading, when I calculate the total power, I need to use this wattmeter's reading, subtract that wattmeter reading. At this moment, there's no load on the motor, and all the loss in the motor to cause those wattmeter reading. Next one, I'm going to turn the eddy current brake on. Before I turn that on, you can see my voltmeter is reading the line voltage, the ammeter reading the line current. But at this moment, even I don't have any load, they're going 3 amps on this ammeter. Now I turn on the eddy current breaker. The eddy current breaker is acting as a load on the motor shaft. So now the motor is fully loaded. I have a 3.4 amps on the line current. Because my motor is rated for 3.4, so now my motor is fully loaded. You can see this wattmeter reading go down below 0 again because now my power factor is above 50%, so both meters should read a positive number, but because I switched the lead, so this reading becomes negative again. Now I'm going to turn the power off, flip the leads again. I change the leads back to normal. I turn the power on. Now my motor is going full amps, but both of my wattmeter is reading positive now. So at this moment, when I calculate the total power, I need to add the two wattmeters reading together to get the total power. And my ammeter is going 3.4 amps. That's the full amp and the line voltage. Now next step, I'm going to add in capacitor in there to correct the power factor. I have a Y-connected capacitor bank. It's a 3-phase capacitor bank. I connect the 3-phase capacitor bank on the motor terminal. Now when I turn the power on, you can see I didn't change anything else. The line current is going to drop lower. At this moment, because the capacitor bank is correct the power factor, you can see my wattmeter wasn't changing too much because my power factor go above 50%, but my line current dropped to 2.15 amps. So when I do the power factor correction, I correct the power factor to about 90%, my line current is going to drop lower. So here is an example showing you how the 3-phase power can be measured by the 2 wattmeter and how we can use capacitor bank to do power factor correction. If you have any questions, you can connect us online or send us an email.